Which of the following skeletal structures represents the Newman structure shown below? So we have our options are all skeletal structures, and our Newman projection is a certain way of looking at a molecule to see where groups are oriented around each other in three-dimensional space. So we need to know how to interpret these Newman structures. So what we have, we've got this circle, and that represents a carbon that's behind another carbon. And so we have a dot in the front that represents the first carbon. So it's as though you've picked up one of these molecules and you've turned it, and you're looking straight from one carbon atom to the one that's behind it. So I'm going to draw this to look similar to what we have over here. So this is my front carbon atom, is that dot. So that is the front carbon. And that would be completely eclipsing the back carbon. So the circle is meant to represent that back carbon. And so the bond between these we can't see because we've oriented the molecule so that we're looking straight down that bond. And so off of that front carbon atom, you have a bond that's sticking straight up, and then one that is pointed down and to the left, and one that is pointed down and to the right. And then off of this back carbon, we have bonds that are angled up and either to the left or to the right, and then a bond that's going straight down. So having all of these bonds spread out like this is a staggered conformation. And this is what we have been drawing all along when we draw these zigzag structures. When you put an alkane in this zigzag structure, you are putting it into its staggered conformation. So when we're looking at our Newman projection, we want to convert from a Newman projection to one of these skeletal structures. We said we kind of picked it up and we're looking down a bond, so now I got to flip it back over. So when we do this, you can technically flip your molecule this way, or you could flip it the other way. I recommend doing it consistently the same way every time, so I tend to knock mine over this way. So what I'm going to say is that everything that's here, these bonds here, are in the plane. And if I take this molecule and I knock it over, the bonds that are on this left-hand side are going to end up going into, so not in means flat with the paper. This means into, pointing away from us, so into the plane. In other words, when I represent those bonds, I'm going to represent them as the dash bonds, the ones that are getting fainter because they're moving farther away from us. And then the bonds on the other side, right, if I flip it over, these are going to be sticking out of the plane of the paper. And we represent those with the solid wedges. So you can think that it is getting more solid, more intense because it's sticking up out at you. So now that we have kind of a guide, we can take a look at our skeletal structure over here. So first thing I want to do is find out how many carbons I have in my longest carbon chain. So I'm just going to start from one end and go to the other end. And this will actually match the IUPAC naming because I see I'm going to hit the alcohol on the lower carbon. So if I have carbon 1 here, I have carbon 2, and now here's something that's really important not to miss. Behind carbon 2 is carbon 3 that's represented by that circle. So we have a third carbon atom in behind there. And then that third carbon atom is connected to the rest of the chain. So we have 4, 5, and we've got this branch point, 2 methyl groups. One of those is going to be carbon 6 and one will be a methyl substituent. So it looks like we have a 6 carbon atom chain. And now we're going to flip it over. So anything that's on that left-hand side, we're going to say that's going away from us. So we're going to put that on the dash bond. And anything on this right-hand side is going to be sticking out at us. So we're going to put that on the solid wedge. And then that carbon backbone is the zigzag that is in the plane. So let's go ahead and, so we see on carbon 1, all right, so here's carbon 1. We've got a methyl group sticking up. So when we put it in its zigzag, it's going to zigzag. So I'm going to put it to the side to match what these structures are. And then I see that I have a hydrogen that's going away from me. And on that same carbon atom, there is an alcohol that is on a wedge. It's sticking out at us. And so that's carbon number 2. And then in behind that, I have the bond to carbon 3. That's what's represented by this Newman structure. And off of carbon 3, I have the alcohol going away from me. And I have the hydrogen that should be on a solid wedge. And then sticking straight down in the plane, I can continue with this carbon chain. So I have carbon 1, 2, 3. So 2 and 3 is what's represented by that structure. 4, 5, 6. And remember, we only counted one of these methyl groups as 6, so we still need another methyl group sticking off of carbon 5, and there it is. And so if we just ignore those implied hydrogens, we can see the 6 carbon atom chain. We can see on carbon 2 that we have the alcohol sticking out at us on a solid wedge. On carbon 3, it's pointed away from us on a dash bond, and then we still have the methyl group on carbon 5.